Hello, my name is Rebecca, and today I'm going to present you my evidence number 2. In this evidence, we're going to see from nutrition to the respiratory system, cardiovascular system, the urinary system, and others. Let's check the case that was demanded for this evidence. Okay, so this is a case which all the next points were based off, and it says like this. Jim is a 21-year-old male in his third year of college, and he has decided that it is time for him to get back in shape. During high school, Jim was active in sports and followed a healthy diet, but the demands of work and study and his social life have taken their toll on Jim's health. He weighs more, doesn't exercise, drinks on the weekends, eats a lot of fast food like hamburgers and french fries, donuts, and pizzas, and he began smoking about 3 years ago. Due to the pressures of study and work, Jim also gets very little sleep. Since Jim has decided to get back in shape, his first step was to get a checkup in the school health clinic. During the physical exam, the nurse measured Jim's height, weight, and blood pressure. Jim is 1.8 meters tall, weighs 19 kilos, and his blood pressure is 132 over 84 mmG Hg. Jim was not concerned until his doctor informed him that high blood pressure of hypertension is a blood pressure of 140 over 90 mmHg or higher. Jim's blood pressure value qualify him as pre-hypertensive, which means that he has an increased risk of developing hypertension in the future. Jim told his doctor that several family members of his dad's side of the family have hypertension, and some had died before the age of 50 of heart attacks. Hypertension is a disease of the cardiovascular system that is correlated with an increase in heart disease, stroke, and kidney disease and vision problems. Most people consider hypertension to be a disease of middle age, but almost 1 in 5 young adults are affected as well, making it one of the major health risks facing young adults. After speaking with his doctor, Jim realized that he knew very little about his body work and had never considered how his lifestyle choices influenced in his health. He was determined to learn more about how his body functions, especially the cardiovascular system. He also wants to work on making positive change in his lifestyle, starting with changes in his diet. He needs your help with his new objectives, and we are going to help you, Jim. Let's see the first one. Let's check the different kinds of risk factors that Jim has for developing disorders of the cardiovascular system. Now, because of Jim's life habit that he's right now, he doesn't only has hypertension. He can also have obesity, osteoporosis, lung cancer, and anxiety. Now, these risk factors that I'm going to continue to say are all the same for these diseases. The definition of risk factors is any attribute, characteristic, or exposure of an individual that increase the likelihood of developing a disease or injury. In this case, we're taking hypertension as a disease. The risk factors are unhealthy diet, physical inactivity, genetics, tobacco use, harmful use of alcohol. The effects of behavioral risk factor may show up on individuals as raised blood pressure, raised blood glucose, raised blood lipids, and overweight and obesity. Point number 2. The cardiovascular system. Now, I found a video that will explain more the cardiovascular system than I'll do it myself. This video is part of the mayoclinic.org, so all the credit goes to them. Let's check the video.
Your heart is a pump. It's a muscular organ about the size of your fist and is located slightly left of center in your chest. Your heart is divided into the right and left side. The division protects oxygen-rich blood from mixing with oxygen-poor blood. Together, your heart and blood vessels comprise your cardiovascular system, which circulates blood and oxygen around your body. In fact, your heart pumps about 5 quarts of blood every minute, and it beats about 100,000 times in one day. That's about 35 million times in a year. Oxygen-poor blood, blue blood, returns to the heart after circulating through your body. The right side of the heart, composed of the right atrium and ventricle, collects and pumps the blood to the lungs through the pulmonary arteries. The lungs refresh the blood with a new supply of oxygen, making it turn red. Oxygen-rich blood, red blood, then enters the left side of the heart, composed of the left atrium and ventricle, and is pumped through the aorta to the body to supply tissues with oxygen. 4 valves within your heart keep your blood moving the right way. The tricuspid, mitral, pulmonary, and aortic valves work like gates on a fence. They open only one way and only when pushed on. Each valve opens and closes once per heartbeat, or about once every second. A beating heart contracts and relaxes. Contraction is called systole, and relaxing is called diastole. During systole, your ventricles contract, forcing blood into the vessels going to your lungs and body, much like ketchup being forced out of a squeeze bottle. The right ventricle contracts a little bit before the left ventricle does. Your ventricles then relax during diastole and are filled with blood coming from the upper chambers, the left and right atria. Then the cycle starts over again. Your heart is nourished by blood too. Blood vessels called coronary arteries extend over the surface of your heart and branch into smaller capillaries. Here you can see just the network of blood vessels that feed your heart with oxygen-rich blood. Your heart also has electrical wiring, which keeps it beating. Electrical impulses begin high in the right atrium and travel through specialized pathways to the ventricles, delivering the signal to pump. The conduction system keeps your heart beating in a coordinated and normal rhythm, which in turn keeps blood circulating. The continuous exchange of oxygen-rich blood with oxygen-poor blood is what keeps you alive.
Okay, so that was a really good explanation of the cardiovascular system. That was point 3, so now let's get with point number 4. Now point number 4 says, let's explain the function of the respiratory system and how it works through the cardiovascular system to achieve respiration. Now the respiratory system, this fellow over here, has the parts on it. The respiratory system contains the organs that allow us to get the oxygen we need and to remove the waste carbon dioxide we don't need. It contains these parts: lungs. These are the lungs, left lung and right lung. Tubes leading from the lungs to the mouth and nose. These are the tubes: the larynx, the pharynx. And lastly, there is a structure in the chest that allow air to move in and out of the lungs. Those structures are a lot. There are the bronchi, alveoli, this is the diaphragma, under our lungs, and so on. Now let's see what's ventilation. Ventilation is the movement of the ribs. Rib muscles and diaphragma allow air into and out of the lungs. Take care, this is called breathing or ventilation, not respiration. When we breathe in, we inhale, and when we breathe out, we exhale. So this is how your examination can show you how your diaphragm really relaxes and passive and active or passive. And here we see it in another way. When we inhale air, our diaphragm curves down, and the lung actually inflates, and the rib moves up and out. If you touch your chest, you can really feel the lungs getting full of air. And when we exhale, the diaphragm muscle relax. The lung deflated, and the ribs goes to normal size. You can see here that the diaphragm goes relaxing and curving down. Now, the interaction between the two systems. The interaction between the two systems, actually they work for the same goal, getting oxygen to tissues and getting carbon dioxide out. The respiratory system is involved in supplying oxygen to the blood and removing carbon dioxide. When the heart receives blood that is low in oxygen and high in carbon dioxide, it comes into the lungs via the pulmonary artery. When the lungs expand and get fresh air from the environment, oxygen is transferred via the alveoli into the low oxygen blood, which also then sends from its carbon dioxide back into the lungs. Now that his blood has fresh oxygen in it, it returns to the heart, and then the heart then pumps it throughout the body. Now this means that it actually comes for the same goal, to get oxygen in and carbon dioxide out. These are the lungs, the heart. And these are the capillary of cerebral tissues. Now let's check the urinary system. Now first let's check each organ and its function. Now we have two kidneys. The pair of purplish brown organs is located below the ribs toward the middle of the back. This means they are in the back of our body, more in the back than the front. Their function is to remove liquid waste from the blood in the form of urine. So those are two kidneys we have. Now we have also two ureters. These small tubes carry urine from the kidney to the bladder. Muscles in the urine wall continue spinning and relax, forcing urine downward, away from the kidney. Now we have one bladder, is this one right here. This triangular-shaped hollow organ is located in the lower abdomen. It is held in place by ligaments that are attached to other organs in the pelvic bone. The bladder flow relaxes and expands to store urine and contracts and expands to empty urine through the ureter. The ureter is a tube allows urine to pass outside the body. The brain signals the bladder muscles to tighten, which squeezes urine out of the bladder. At the same time, the brain signals the muscles to relax to let urine exit the bladder through the ureter. Now, how is like the spray that follows urine? Well, first it starts everything in the kidneys, on these two kidneys. Fun fact, a human can live just with one kidney, but actually need to be more careful. But you can definitely survive with one kidney. Now this is a nephron. It's the basic structure and functional unit of the kidney, and its chief function is to regulate water and soluble substance in the blood by filtering the blood, reabsorbing what is needed, and excreting the rest of urine. Its function is vital for homeostasis. It is regulated by the endocrine system by hormones such as antidiuretic hormones, aldosterone, and parathyroid hormone. Now I'm going to put another video, and this video, what it's going to explain is actually how urine is formed. It's the process of your information. You're using examples of substances that are filtered, reabsorbed, and exert. Now let me show you with this video.
Urine is formed by three processes in the nephron, the functional part of the kidney. In glomerular filtration, the glomerulus filters water and certain dissolved substances from the plasma of the blood. This results in increased blood pressure, which forces the plasma-like fluid from the blood into Bowman's capsule and then into the tubules. The fluid or filtrate include many positive and negative ions of many elements. The filtrate does not have any proteins or red blood cells, which are too large to pass through the capillary membrane. In tubular reabsorption, substances are transported out of the tubules and back into the blood of the peritubular capillaries. Reabsorption takes place in the proximal tubule, loop of Henle, and distal tubule. The major part of reabsorption occurs in the proximal tubule. About 15% of water is reabsorbed back into the bloodstream. The process is regulated by the hormones vasopressin and aldosterone. In tubular secretion, substances move from the plasma in the peritubular capillaries back into the filtrate in the renal tubules. The proximal tubule secretes creatinine and histamine, and the distal tubule and collecting duct secrete potassium into the filtrate. All the tubules actively secrete hydrogen ions to regulate the pH of the body fluids. The filtrate is now urine. Urine is about 95% water with a balanced urea, uric acid, amino acids, and electrolytes. The daily production is about 0.6 to 2.5 liters per day. Urine production below 30 milliliters per hour indicates possible kidney failure.
Okay, so that was the explanation of the function of the urine. More than the function, sorry. The process of your information. Now let's go with our final point to help Jim. BMI of our friend Jim. Now BMI stands for body mass, and this is the body mass of Jim. Now, what happens if you also want to get your body mass? This is how I get the body mass on Jim. If you have your weight on pounds and your height on inches, you just use this conversion factor over here. But it's more easier if you have it in kilograms and on meters. So you just put your kilograms and your meter squares, and that'll be it. Remember that in the beginning that actually told us how much weight had Jim and how much height he had. He had a weight of 19 kilograms and a height of 1.80 meters square. So that gives a total of 27.77. Now this means he has overweight. He's on the midpoint of overweight. Not near obesity, but not near healthy weight. So let's remember that also Jim wanted us to help him with his diet. Now let's see what we can help him. These are some points that you can use, and our friend Jim will use as too. Focus on fruit. Eat a variety of fruit, fresh, frozen, canned, or dried, rather than fruit juice or most other fruit choices. For a 2,000 calorie diet, you will need 2 cups of fruit each day. An example of 2 cups is 1 small banana, 1 large orange, and a quarter cup of dried apricots or peaches. Vary your veggies. Eat more dark green veggies such as broccoli, kale, and other dark leafy greens. Orange veggies such as carrots, sweet potatoes, pumpkins, and beans and peas such as pinto beans, kidney beans, black beans, garbanzo beans, split peas, and lentils. Get your calcium-rich food. Each day, drink 3 cups of low-fat or fat-free milk. Or you can get an equivalent amount of low-fat yogurt or a low-fat cheese each day. 1.5 ounces of cheese equals 1 cup of milk. Remember, we need to drink 3 cups of low-fat or fat-free milk. If you don't or can't consume milk, choose lactose-free milk products and or calcium fortified foods and drinks. Make half your grains full. Eat at least 3 ounces of whole grain cereals, bread, crackers, rice, or pasta each day. 1 ounce is about 1 slice of bread, 1 cup of breakfast cereal, or half a cup of cooked rice or pasta. Now remember that it needs to be 3 ounces, so don't get really excited about that. Just 3 ounces, like equals 3 slices of bread. Go lean with protein. Now that can be really easy actually. To get to go lean with protein, choose lean meats and poultry. Bake it, broil it, or grill it. Vary your protein choices with more fish, beans, peas, nuts, and seeds. Limit saturated fats. Get less than 10% of your calories from saturated fatty acid. Most fats should come from sources of weird names that you cannot even pronounce, such as fish, nuts, and vegetable oils. When choosing and preparing meat, poultry, dry beans, and milk or milk products, make choices that are lean, low fat, or fat free. Limit salt. Get less than 2,300 milligrams of sodium. That's about 1 teaspoon of salt each day. Now, the evidence question that we need to get 10 dietary recommendation to improve his overall health. Here are 7, but this is what I'm gonna complete, you guys. This is a menu for men's, so this is perfect for Jim. He has a total calories of 1,793.4 calories, which is high in protein, low in fat, and also high in carbohydrates. Now, for breakfast, he can eat a tomato and basil omelet. This is the recipe, and here it says how many calories it has, how many proteins. You can see that the egg white has the most protein of all. Now, with this breakfast, he has a total of 160 calories. For the first snack, this menu counts of 3 snacks. He can have 25 almonds and 1 medium apple. That can actually really fill you up. Actually fills you more than your breakfast, so don't go really crazy with the snacks. Now for the lunch is a grilled chicken breast with a lot of fruit, a lot of veggies, and these are the final calories. Again, they're going really high on protein. For snack number 2, try a fat-free yogurt. And now you must sure that it's fat-free because you can see just a 6 ounces fat-free yogurt equals to a really good balanced breakfast. And for dinner, it's basically the same as the lunch, but with more cheese, so that means more protein. That means also more veggie from the lettuce. Marinara sauce has salt, so that goes the salt of all the day. And it's really high in calories, but still good for you actually. Now, for snack number 3 and final, a medium banana and whole wheat pretzels. Now, this is a very complete menu, and just with seeing it actually gets me full. Now, you may say that this is too much or too less. Now let me tell you, it's perfect. Now, this is for somebody that doesn't max exercise. If you are making exercise but you're a man, you probably need to take more than 2,000 calories per day. So actually this means this is perfect for you if you're not doing any exercise or not a really demanding exercise. This is just perfect, and you can see it's gonna pull you up. So this is the wrap, guys. This is the final of my evidence 2. I hope you like it. I'll put the links down below of where I got all this information, as well as the document where I have everything more explained. Thank you so much for watching, and see you on